Hello, geometry. Welcome back to regular polygons, day 2. Now, we're going to try to find the area inside of a regular octagon with a given apothem radius or perimeter, and a regular pentagon with apothem radius and perimeter. I'm sort of zooming in a little bit, so it's a little bit easier to see. I'll try to focus every once in a while too. I think that we should be okay. All right, and I'll pan out later and show the whole thing, or I'll scan it. But you guys can certainly zoom into different parts as we see them. Now we're going to need our calculators. Okay. Now, interestingly enough, got to be in degree mode for sure, because when we're using SOHCAHTOA with right triangle trig, you got to use degree mode. Okay, now I haven't done these yet, so I hope I don't mess up. All right, this guy, regular octagon. If you remember from our page that we just did, where we figured out what the angles inside of an octagon were, we found out that the inside of an octagon has 22.5 degrees up there. So we don't need to do any extra work. It's always going to be 22.5 degrees. So what I'm going to do is, since that's 22.5 degrees, I'm going to sort of blow this up to the side here a little bit. And I'm just going to say, all right, that's 22.5, that's 67.5. If my apothem is 8, there's no need for me to really find the radius, because all I need to do is find the bottom, and that's how I'm going to get my perimeter. Okay, so I'm going to use, let's see, I think I'm going to use tangent. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Unbelievably important skill to have for the rest of your mathematical life, right triangle trig. So I'm going to call this, I don't know, x. So my tan of 22.5 is equal to opposite over adjacent, and with a cute little 8 times the tan of 22.5. Again, a little bit simpler than needing to do special right triangles, 3.317-ish. So that's this. This is 3.317-ish. Now, I'm not going to use that. I'm not going to use a rounded number. I'm going to use an exact number. So I'm going to multiply that by 2 to get one of my sides, 6.627-ish. Now, I could have just multiplied it by 16 to get the whole thing. But some of us are a little bit more comfortable multiplying that by 8 to get our whole perimeter. Now, that's my perimeter. So all I got to do now, I guess I could write it. Perimeter is 53.019-ish. Now, all I got to do is go 1/2 apothem perimeter, and this was actually a very, very quick and simple procedure. So I'm just going to do really 4 times that, or go times 4, and there is our 212.077. No way to keep an exact number because this is trig, and trig's not giving us exact values. Okay, I really like the lighting on this. Okay, now I'm going to number 2. What if the radius is 8? What if the radius is 8? Well, if the radius is 8, that means that that's my hypotenuse. Now, you can pick whichever one you want, but I do need to find the bottom. I'm going to go ahead and use the 67.5 for variety. So I'm going to go, what was that? Cosine. Adjacent hypotenuse. So the cosine of 67.5 is put that nice for you. Adjacent over hypotenuse, a little 8 times the cosine of 67.5. Trig, save my life. Trig, save my life. 8 times that, I get a 3.061-ish. So that's this guy. But now I got to multiply that by 16. And again, you can multiply it by 2. And then you can multiply it by 8. But 2 times 8 is 16. So you're just going to multiply that by 16 to get a perimeter of 48.983. Now time out, because we don't have the apothem. You say, oh, to find the apothem, let's just do another trig thing, which is great. But remember, you can use Pythagorean theorem, especially with your calculator. So I'm just going to go, what is the square root? Remember, it's this squared plus this squared equals this squared. So I'm just going to go, what's the square root of 8 squared minus what I just found squared, which is sitting right there in the answer 2 above, or you can type it in. You can arrow up if you have this kind of a calculator, or you can just write out some numbers of it. And what do you know? You have 7.391-ish. And of course, it should be smaller than the hypotenuse because the hypotenuse is always the longest. And now, lucky, I've got the apothem. I've got the perimeter. I don't really care if I'm a little bit off on my rounding, because I'm not going to round. I'm just going to use my calculator and go 1/2 times the apothem, which was the 7.39 number, which is answer, the most recent thing I found, times the perimeter, which is either written down or stored in my calculator, and we get 181.019-ish. Okay, this is good. So we got a couple of these done. Those weren't too painful. I'm going to go over here, and when the perimeter is 8, of course, I'm just going to divide the perimeter by however many sides there are. 8 in this case. Here's my cute little triangle again. I'm going to get a little bit bigger. It looks a little skewed, but that's, what do we got? 22.5. Now, this is 1/2. So I already know my perimeter is 8, so I could already go, hey, 1/2 times the apothem times the perimeter. All I need is the apothem. All I got to do is find this little guy right here. So I'm just going to use a cute little 67.5 tangent. So I'm going to write it out again. Tan of 67.5 is apothem over opposite over adjacent. Opposite over adjacent. So now I'm just going to multiply the tan of 67.5 by, my wife is providing musical accompaniment in the background, which is nice, times 0.5, and I got 1.207-ish. Now that's kind of nice, but I'm going to use this number, of course. So now I'm just going to go 1/2 times the apothem, which was the last number or answer, times the perimeter, and we get a whopping 4.828. Now that's not very big, but that's okay because it's kind of a small shape. And so there's our first 3. Now that was octagon. Now if I go, there's octagon. 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 What happens when you get rid of your octopus? Octagon. Okay, now let's look at pentagon. Now pentagon seems a little simpler because it's only got 5 sides, which is fine. So my first of all, my apothem is 5. Next time, my radius is 5. And feel free to go back to your ones from the other day and just use trig instead. This one, my perimeter is 5, which is really clean. That means all of these are 1, which that is 1/2 as well. I reference my pentagon sheet. I noticed that my pentagon has a 3654. Good old 365490. Whoop, whoop. Now, I'm going to blow this guy up here. And if this is, there we go. If this is a 365490, and I've got a 5. I just need to find this bottom side. So here we go again. You can do whatever trig you want. I'm just going to go ahead and use tangent again because it's kind of clean. Tan 36 is opposite over adjacent. See how this can go kind of fast. So I'm just going to go 5 times tan 36. There's my 3.632. 3.632 times 2 times 5. Or, of course, just multiply it by 10, because that's going to be it. And I've got 1/2 times the apothem times the perimeter, 36.327-ish. And I get this really pretty, well, times 5 divided by 2, 90.817. That's nice. This guy. Okay, same triangle, same triangle. This is really great, kids. We got a nice little routine going on. This is 5. This is 54. Oops, that was almost tragic. This is 36. Let's call that x. Let's go with cosine again. You feel bad for sine? You feel bad for sine? Don't feel bad for sine. It's fine. It gets used the most anyway. Cosine of 54 is adjacent over hypotenuse. I'm going to go 5 times the degree mode. Mr. Mac, why are all my answers wrong? You were in degree mode. 5 times the cosine of 54. Hey-oh, 2.939. Let's multiply that by 10, which is kind of silly. I could have just moved the decimal place over 1. Well, it's fine. So now I'm going to go 1/2 times the, oh, nuts. I didn't find the apothem. Hey, let's use sine. Hey, we were just talking about sine. Oh, I'm going to call that A. So let's go sine of 54 equals A over 5. Good old 5 times sine of 54. We have a great opportunity here. 4.045-ish. Now, look at this. You know how trigonometry and Pythagorean theorem agree, right? So I should be able to go to find A. Let's go square root of 5 squared. Let's see if this math stuff knows what it's. Let's see if this agrees. 5 squared minus. Now we found x was this 2.93. So I'm going to go all the way up and find that guy. And now if I hit square root, I'm going to get this 4.04. I better, or something's broken. And then clickety click, barber trick. Hey, oh, look at that. Of course it worked. So I'm going to go 1/2 times the apothem times the perimeter, which was that 29.389-ish number. So I'm going to be careful here. 1/2 times apothem times perimeter, which is way up there. You can see the blue kind of going up. Hey, look, I've got 59.441. I bet you're sad I'm only giving you 6 of these. You were like, I want more, but that's why there's bonus problems. Woot, woot. Now, last one. Okay, this guy. If my perimeter is 5, each side is 1, which is nice. I got my cute little triangle here. All I need is that's right, the apothem. So I'm going to just find the apothem. I'm going to just be classically going with tan of 54 equals A over 1/2. I'm going to do a little 1/2 times the tan of 54. You want to do these because your teacher next year is going to be like, hey, how'd you use trigonometry to find the blah, blah, blah? And you'd be like, oh, I remember. That was so cool. 0.5. I'm going to ask him. Mrs. Mack is going to be like, hey, well, what did I just do there? I got distracted. Talking to Mrs. Mack. Okay. She's going to be like, hey, you guys know your trig? Woohoo! So she doesn't really say woohoo, but she's very happy when kids know their trig. 1/2 times the tan of 54. What button did I push? So I'm going to get that, which is my up. Oh, it's not even 1. Well, of course it's not 1, because this whole thing is 1, right? The whole side, 0.688. So now I've got my 1/2 times the apothem, not the opossum, the apothem times perimeter. So I'm going to go 1/2 times the apothem times the perimeter. 1.720. Hey-oh. Now that was cool. So I hope these are right. There's my apothem 5, little close-up view. There's my radius 5 and a pentagon, little close-up view. There's a perimeter 5, little close-up view, which is great. So all of that to say, there we go. Now you've got 6 problems to do that are just like it. It's like I'm doing the same thing. Look at this. Whoop, whoop. Hey, instead of 8, 8, and 8, it's 5, 5, and 16. Instead of 5, 5, and 5, it's 6, 8, and 10. 6, 8, 10. It's kind of cool. Why was 2 afraid of 4? Why was 4 afraid of 6? Because 6, 8, 10. Okay, so anyway, there's your homework. These 6 problems right here. But then there's bonus problems. Bonus problem number 1. Can you find the area of a regular decagon? And these are all on the PDFs, which I'll send you, and they'll be on Google Classroom. Can you find the area of a regular decagon with apothem 10? You know what a decagon is? It's a 10-sided shape. You know what a decagon also is? That's what happens when a tornado hits your backyard. Boom. Can you find the area of a regular decagon with a Potham 10? Whoa. Can you find the area of a regular dodeca 12gon with radius 12? Sweet. Can you find the area of a regular septagon 7gon with perimeter 21? And super bonus for another bonus point or more. What is the radius of a regular nonagon, 9 sides, with area 100? What? So I gave you the area, and you got to go backwards. What? I bet you can do it. I believe in you. Of course you can do it. Of course you can do it. It's going to be amazing. I believe in you. Okay, so there's the whole thing in one fell shot. You can see the whole dealio right there. I'm great with this camera work, I know. Hold on. Up a little higher. Up a little higher. That, I'm sure, is great to watch. So there it is. There's that whole page right there with all the answers. Hope you learned something good. Please send me messages and make sure that you understand what's going on and send me questions if you need it. All right. Thanks, everybody, for joining me. Bye-bye.